My problem number 17. This is a limit problem which is also part of calculus, and it reads this way. If the limit as x approaches c of f of x is 0 and the limit as x approaches c of g of x is equal to 0, then what can be concluded about the value of the limit as x approaches c of f of x over g of x? And well, the properties of limits tell us that the limit of a quotient is equal to the quotient of the limits. And so the limit as x approaches c of f of x over g of x is the same as the limit as x approaches c of f of x over the limit as x approaches c of g of x. And since both of those are 0, we'd end up with 0 over 0. Now, 0 over 0 and infinity over infinity are what are called indeterminate values, which means that we can't tell what they are just by looking at those values. You have to use some type of algebraic procedure, or perhaps even to use your graphing calculator to try to evaluate what that limit is. We can't tell just by looking at the functions as they are there. So this value is not 0. You may be used to seeing that anything 0 divided by anything is 0, but 0 divided by 0 is not 0. And the same thing with infinity. And you've also heard anything divided by itself is 1. But 0 over 0 is not 1, and infinity over infinity is not necessarily 1. 0 over 0 could be 1. We don't know without looking further. So the answer to this question is that the value can't be determined from the information that's given. Unless you know exactly what f of x and g of x are, and you know how to go about evaluating that limit, or know some procedures for evaluating that limit, you really can't tell. Now there are other types of indeterminate values also. For example, 0 times infinity, or infinity to the 0 to the infinity power, or there are other ones, but for this particular test, the ones that you really want to know, be able to identify as indeterminate, are 0 over 0 and infinity over infinity. And then there are a number of strategies that you could use to evaluate them. Now, what are those strategies that you could use? You could factor the numerator, factor the denominator, and try to cancel the denominator. Try to cancel any factors in the denominator that would make the denominator 0. For example, we could say the limit as x approaches negative 1 of x squared minus 1 over x plus 1. Well, if we were to plug in negative 1 into the numerator, we'd get negative 1 squared, which is 1. 1 minus 1 is 0. If we were to plug in negative 1 into the denominator, we'd get negative 1 plus 1, which is 0. We'd get 0 over 0. As it stands, that is an indeterminate value. It doesn't mean that the limit doesn't exist. It means that we can't tell what it is without looking at it further. And what we would do with that, in this particular case, the algebraic procedure that we would use would be to factor the numerator and then to cancel the x plus 1 factors. At which point, the value, or the factor that becomes 0 when we plug in x equals negative 1, goes away. And at this point, the numerator will not be 0, and we will have something that we can actually evaluate. So we have the limit as x approaches negative 1 of x minus 1. We would just substitute x equals negative 1. We'd get negative 1 minus 1, which is negative 2. And so in fact the limit does exist, but it was in an indeterminate form, 0 over 0, and we had to do some algebraic procedure in order to find out, to determine what the limit actually was. There are a number of different techniques. There are 3 basic techniques. But I won't cover them in this particular video. So that is something that is important, being able to identify a limit in an indeterminate form, and then either to know whether you have enough information or to use an algebraic procedure to simplify it in such a way that you can substitute the value negative 1 or whatever it is for x and come up with an answer.